Welcome to Edusary Lessons. This lesson is titled, Prove Two Triangles Are Similar. Read the learning objective with me. Ready, read. We will prove two triangles are similar. Activate prior knowledge. Ready, read. Are the following ratio equations true? Taking a look at problem number 1, we see that we have three ratios. And we want to know, do they all reduce to the exact same value? That's what equal means. So we can start to reduce each one of these fractions and see if they reduce down to the same amount. Let's start with the fraction 10 over 15. We could divide the top and the bottom by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Let's take a look at the ratio 8 to 12. We can divide top and bottom by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So far we have equal ratios. Let's check the last one to make sure that we have a complete true equation. We can divide 6 by 3 and 9 by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And our third fraction also reduces down to 2/3. Let's read the final statement for problem number 1. Ready, read. The ratio equation is true because they are equal value fractions. Go ahead and try answering this question for number 2. The first fraction, 12 over 9, both values can be divided by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. The next fraction says 7 over 7, which is another form of 1. So already we know that these two ratios are not equal. It is enough to say that this ratio equation is not true. Let's go ahead and check the third fraction. 6 and 4 can both divide by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. All three values are unequal. Let's read the final statement. Ready, read. The ratio equation is false because they are not equal value fractions. Well, you already know how to simplify a ratio. Now we will use ratios and triangle properties to help us prove two triangles are similar. The concept development. Let's read this statement. Ready, read. Two triangles are similar, and we use this tilde notation, if they have the same shape. Similar triangles can be different sizes and rotations. So let's take a look at a similar triangle to this first triangle. We can see it's the same triangle. It's getting bigger while rotating, but it's the same shape. Right, let's take a look at this smaller triangle. This is also a similar triangle, it's just smaller. This one has no rotation, so let's watch this one shrink in size but never change its overall shape. This is a lot like when you work with images on a device and you zoom in or zoom out. It's the same image, you're seeing it bigger or you're seeing it smaller. If you rotate the image, you're just seeing it at a different angle, but it's the same image. This picture of me down here, this is a similar image of me because it's a smaller size. So that's what we mean by the same shape. Let's read the question. Ready, read. Which of the following sets of triangles appear to be similar? You will select from triangles in set A, these three blue triangles, or the triangles in set B, these three red triangles. Be ready to explain how do you know. So we can say that A or B is a set of similar triangles because, and then explain our answer. I'll give you a moment to think of your answer. All right, let's check your answer. That triangles in set A appear to be similar, and we know that because the first triangle is only a different size than the second one, and the first triangle is only a rotation of the first one. B, these two first triangles look completely different, not because of size or rotation, but because one is heavily stretched. We use this word appear to be similar because it's just an approximation. It's really hard to tell for sure. But we do have a way to be able to tell for sure, and that's what we're going to get into, especially when we think about this word prove two triangles are similar. If you're going to prove something, it's like proving it in a court of law. You need to have a really good reason, a really good explanation. It can't just be that, oh, it appears that they did something. We need some proof. So let's talk about what type of proof we have. The different ways that we can prove two triangles are similar. These are called the similar triangle theorems. Theorems means that it's a proven two-way statement that is always true. The first theorem that we have is called angle-angle similarity, abbreviated AA similarity. Before we read the angle-angle similarity theorem, we have this two-way arrow, and in mathematics, the two-way arrow to represent the phrase if and only if. And the power of if and only if is that we could actually read this theorem both ways. So let's read it starting from the left to the right. Ready? Read. Two triangles are similar if and only if the two triangles share two equal angles. Read it from the right to the left, starting here with the triangles. Ready? Read. The triangles share two equal angles if and only if the two triangles are similar. All right, so if we know two triangles are similar, then we know that they share at least two angles for sure. But the way that we primarily use this theorem is to find similar triangles, and this is one way we can find them. If we can show two triangles share two equal angles, then we have proven that these two triangles are similar. In this example, this first triangle I'll put A, and the second triangle I'll label B. Triangle A is smaller than triangle B. Triangle A has been rotated. The blue angle of triangle A is equal to the blue angle of triangle B, and the green angle of triangle A is equal to the green angle of triangle B. So let's apply this to a question. Ready? Read. Which of the following triangles appear to be similar? How do you know? We have three triangles in our set, and we know the value of two angles are given because each one has a numeric shown angle, and we also know that they have a right angle, which of course stands for 90 degrees. So go ahead and think of your answer, and you can say triangles blank and blank are similar because, and then explain your reasoning. I'll give you one moment to think about what your answer will be. Let's answer this question. So we know that triangles B and C are similar triangles because these two triangles share two equal angles, and those two equal angles are a 90 and a 90 degree, 55 and a 55 degrees. All right, and triangle A only shared the 90, but the other two it did not. But we need to make sure that for angle, that's why it's two angles, that you need to have two equal angles. Let's check our answer with the animation. And I drew that arrow almost right on top of the answer arrow. Great. Here is another theorem that we have for proving two triangles are similar. This one is called the side-side-side similarity theorem, or abbreviated SSS. Just like angle-angle, which required two angles to be equal, this one's going to require a condition of all three sides of our triangle. So let's go ahead and let's read our statement. Remember, the double arrow in a theorem stands for the phrase if and only if. Let's read. Ready? Read. Two triangles are similar if and only if all corresponding side ratios are equal. Here we have two similar triangles. The colors match the corresponding sides. One easy way to recognize what the corresponding sides are: the smallest side length will match up with the smallest side length. The biggest side length will match up with the biggest side length. And the middle will match up with the middle side length. And if you take these ratios that these pairings create, you get fractions 10 to 15, 8 to 12, and 6 to 9. These numbers may sound familiar from earlier. We actually proved that these were equal value fractions, that these ratios were all the same value. Let's go up here to the similarity theorem. If we can show that all corresponding side ratios are equal, then that proves that the two triangles are similar. It's your turn to apply the side-side-side similarity theorem. Let's read the question. Ready? Read. Which two triangles are similar? We have triangle A, B, and C. And how do you know? Option 1, triangle A is similar to triangle B. Or option 2, triangle A is similar to triangle C. They give us the ratio and show us what the fractions reduce to. I'll give you a moment to think of your answer. And think of your answer in the frame of triangles blank and blank are similar because, and then give your reason. Let's look at the answer. Triangles A and C are similar because the corresponding side ratios are all equal. We see the reduced fraction of 1/2, 1/2, 1/2, and these are all equal fractions. And 5/3 is not equal to 4/3, which is also not equal to 3/2. Triangles A and C are in fact similar triangles, and we proved it by side-side-side similarity theorem. Skill development and guided practice. Ready? Read. Which of the following triangles is similar to triangle ABC? And here's the graphic for triangle ABC. We know the 3 angle measurements, and we know the 3 side length measurements as well. We have 2 triangles that we want to know, are they similar to triangle ABC? And we have our similarity theorems that we can use over here. We could either use angle-angle similarity or side-side-side similarity. Let's read the steps. Step number 1. Ready? Read. Identify which similar triangle theorem to use. Alright, so if I'm doing problem number 1, I can either use angle-angle similarity or side-side-side similarity. Which one I will use depends on what information I have given to me in the problem. If I take a look at triangle JKL, I don't know how long the side from J to K is in terms of distance, and I don't know the side distance for any of the sides. What I do know is they have given me 2 measurements that are angle measurements. Use the angle-angle similarity theorem since I only know angle measures. Alright, let's continue to step number 2 and let's read where it says determine. Ready? Read. Determine whether the triangles are similar. Alright, how do we use the angle-angle similarity to determine if the 2 triangles are similar? Well, the 2 triangles are similar if and only if the triangles share 2 equal angles. I need to find equal angle measure. If I'm triangle JKL, I'm asking triangle ABC, do you have an angle of 78? Triangle ABC does have an angle of 78 degrees. We need 2 angle measures to be equal, so let's check the next angle, 45 degrees. Triangle ABC, do you have an angle measure of 45 degrees? Yes, you do. So triangle ABC is similar to triangle JKL. So let's check our answer. We use the angle-angle similarity. We see that angle B here on the ABC triangle is equal to the angle K. Angle C, 45 degrees, is equal to angle L, 45 degrees. So we do know that these 2 triangles are similar, and our proof is the angle-angle similarity theorem, which says that if 2 triangles share 2 equal angles, then these 2 triangles are similar. Alright, so let's read step number 3 to finish the problem. Ready? Read. Use geometry notation to write the similarity statement. So let's take a look at triangle ABC. What's the matching point from J, K, and L? Well, we just showed that angle B and angle K are equal measures, so in that second spot, we could put a K. and angle C, we saw that that matches with angle L, leaving us with the only remaining letter to be J. Triangle ABC is similar to triangle JKL. Alright, and there you have it. Triangle ABC is similar to triangle JKL. Now let's use this geometry notation to read our final statement. Ready, read. Triangle ABC is similar to triangle JKL because the triangles share two equal angles. Let's take a look at problem number 2, and I'm going to guide you to do this problem. Are you ready to read step number 1? Ready, read. Which similar triangle theorem do you think we should use for problem number 2? And I want you to frame your response. The similar triangle theorem to use is because, and then explain your choice. The similar triangle theorem to use is angle-angle similarity because the given triangle NOM shows us the values for two of the angles and none of the values for any side measures. Alright, so let's check our answer. And yes, angle-angle similarity is the similar triangle theorem to use. Let's do step 2. Ready, read. So now I want you to use angle-angle similarity and tell me, are these two triangles similar? Be ready to say your response in the frame of, the two triangles are or are not similar. I know because, and explain your reason. The triangles are similar because they have two equal angles, 57 degrees and 78 degrees. All right, and let's read step number 3. Ready, read. All right, so remember how we matched up the letters to letters by matching up equal angles. What order would we put N, O, and M to match up with A, B, and C? I'll give you a moment to write your final statement like we have written over here in problem number 1. Triangle ABC is similar to triangle NOM. Angle A matches the value of angle N, so A to A, B to O, C matching up with the last letter M. Let's read the final similarity statement for problem number 2. Ready, read. Triangle ABC is similar to triangle NOM because the triangles share two equal angles. Let's try practice problem number 3. Let's read step number 1. Ready, read. Identify which similar triangle theorem to use. Okay, so for problem number 3, if I need to determine which similarity theorem to use, I'm now once again looking at the triangle and what are they giving me? Now I don't know the value of any of the angles, but I do know the value of all the side lengths. I am going to use side-side-side similarity because I know the value of all the side lengths and because I also don't know any of the angle measurements to use angle-angle similarity. And there it is, side-side-side similarity. All right, now let's read step number 2. Ready, read. Determine whether the triangles are similar. Okay, so remember with side-side-side similarity, we need to verify that all of the side ratios are equal. We need to find the corresponding side lengths. Then we know that when we set up the ratios, we need to be able to match up the longest side to the longest side, the middle side to the middle side length, and the lowest side length to the lowest side length. 3.5 over 7 is equal to 3 over 6 is equal to 2.5 over 5. If you think of 7 like $7, half of $7 would be $3.50. 3.5 to 7 is 1/2. The fraction 3/6 reduces down to 1/2. If you have $5 and half of $5 is $2.50, so this fraction is also 1/2. All the side ratios reduce down to the same value. Therefore, these are all equal. And furthermore, that tells us that these two triangles are in fact similar by side-side-side similarity theorem. All right, so we have determined that the two triangles are similar. Let's read step 3. Ready? Read. Use geometry notation to write the similarity statement. Now in this case, to try and figure out what's our correspondence between triangle A, B, C to these letters D, E, and F, if you take a look at angle A is between the shortest or the smallest and the longest side. So what letter angle is between the shortest and the longest in this triangle with the labels of F, D, and E? Well, here's the shortest and here's the longest. So angle A will correspond to angle E. All right, now we can choose angle B just to go in order here. And now angle B is between the shortest and the middle length side. And over here, that would represent angle D, which is also between the shortest and the middle side. So for the last correspondence, angle C will correspond to angle F, not just because it's the only one left over, but also because angle C is the angle between the middle and the longest side length. So we can put F. And to complete our triangle notation, we'll use the triangle symbol EDF. All right, so let's write down our geometry notation. Our geometry notation is that triangle ABC is similar to triangle EDF because all side ratios are equal. I'm going to guide you to do problem number 4. Let's start off by reading step number 1. Ready? Read. All right, so go ahead and determine which similar triangle theorem to use, and you have your two options. And I want you to say, the similar triangle theorem I will use is, and how do you know? The similar triangle theorem to use is side-side-side similarity because the triangle in problem 4 gives us the 3 side lengths, none of the angle measurements. All right, we are ready for step number 2. Ready? Read. Okay, so I want you guys to think of your response in the frame that the triangles are or are not similar because, and how do you know? Remember, with side-side-side similarity, you're looking for all ratios to be equal in these corresponding sides. Don't forget to match up the values, short, middle, and long. Okay, so the ratios should be 14 to 7, those are your long sides. 12 to 6, those are your middle sides. And 10 to 5, those are your short sides. All the values on one side should all come from one triangle, and all the values on the top should all come from the other triangle. Don't swap them. 14 divided by 7 is 2, 12 divided by 6 is 2, and 10 divided by 5 is 2, or they all reduce to equal or the same ratio. We do know that these two triangles are similar because of side-side-side similarity. Let's read step number 3. Ready? Read. All right, I will give you a moment to properly match up corresponding angles to create our statement that will be similar to triangle ABC. Triangle ABC is similar to triangle IGH because A is between the short and the long, and I is between the short 10 and the long 14, and B is between the short and the middle, and G is between the short and the middle, which means that C, the remaining angle, corresponds with angle H. And let's continue our statement. Let's read this one last time. Ready, read. Triangle ABC is similar to triangle IGH because all side ratios are equal.